we won't understand as well. Anyway, any type of extreme weather that depends on that will be more uncertain compared to sea level rise or just the overall amount of water vapor. So extreme weather is influenced by both the most certain aspects of climate change, like temperature and water vapor and sea level, and the uncertain aspects, like the changes in the atmospheric circulation and the distribution of rainfall on the planet. So how much we know about any type of extreme weather event is going to vary depending which type of event we're talking about. So when people say, so this is the first basic message, when people say, because of global warming, extreme weather events are becoming more frequent and more severe. There's no such blanket statement you can make. There's all different kinds of extreme weather events, and it really depends which one you're talking about. Some may be increasing, some may be decreasing, and some we don't know. It may be overall true in some broad sense, but it's not true about everything uniformly. So let's start with the simplest one, heat waves. Heat waves are becoming more frequent and more intense because it's getting warmer. It really is almost that simple. So this is a map of a heat wave. It's the temperature anomaly. This was in 2013, September 2013. There was a big heat wave in Australia. This is a map showing the average temperature deviation from average for the month of September, that month. And you know, it's up to 3-4 degrees Celsius. Remember, it's about double that to get Fahrenheit almost. So you know, this is 7-8 degrees of above average for the whole month. So that 7-8 degrees above average for a day wouldn't be that big of a deal, but if that happens for a whole month, it's very, very hot indeed. And there were all kinds of bushfires and everything. Something like this can happen. You know, you could have heat waves in the past, but however you define a heat wave, normally we make definitions like, well, it's such and such, it reaches such and such a temperature for so many days. Well, that depends, of course, on the day-to-day weather fluctuations. But if you, in the simplest case, just imagine that those day-to-day fluctuations sort of stay the same, but you just raise the whole level of everything by a degree or two, then you're going to cross any threshold for a heat wave more frequently. And that's been happening. So we really do, this is something that's not a model projection. We already can see this in the observations, that heat waves are becoming more frequent and more severe in ways that we are very difficult to explain without invoking global warming. So that's the case that really is the simplest. And climate models and weather prediction models can simulate this well, and it's really not, there's not much uncertainty about it at all. So just to give an example, to bring it a little more home, since Australia is further away, this is New York City, where I live. Well, you guys live pretty close to it. It wouldn't be very different here. These are some projections from the New York City Panel on Climate Change, which is a local group consisting in part of Columbia faculty that advises the city on what's going to happen. And this is the projections of the average number of days in New York City that exceed 90 degrees. And so the historical average is about 18. For the 2020, we expect somewhere around 30, with some uncertainty range, and more like 40 to 50 by 2050. And if you were to ask about the number of days over 100 degrees Fahrenheit, well, the total numbers would be much fewer, but the increase would be just as much or more. So I think this is, when we talk about climate change, and especially when I get calls from reporters, I usually get them about the extreme events, when there's a hurricane or something. But the simplest fact of it is just the warming, and I think that it's hard for us to grasp this until it happens, but we really are going to be living in a hotter climate than we're used to. And the ramifications of that are going to be many. But okay, let's go on to something a little more, so on the other hand, so not every extreme event is becoming more frequent and more intense. The cold ones are becoming less. So if you don't like cold weather, it's good. So this is a sort of complicated form of graph, but what it shows is the average temperature of the coldest days in fall in the northern hemisphere. So the horizontal axis is time. So this is from observations, not a prediction, and the y-axis is latitude. So this is taking all the longitudes over that latitude. So New York is about 40, is about here, and this would be getting up towards the pole, 75, 80 degrees. So you have blues shading to reds, which means that the coldest days, this happens to be for fall, it would be the same if you looked at winter. The coldest days just are less cold than they used to be. So the cold snaps are becoming less frequent and less intense. Notwithstanding the fact that, like a couple of years ago, we had some very cold winters, and there was a lot of press about, is this happening more because of climate change, even though it seems paradoxical because there are cold days and this climate change, how could it do that? There's arguments about how changing the circulation could do that, and we're still arguing over whether in some limited way that could be the case. I'm not convinced myself, but there's, but on average, the cold days are less cold. There's no question about it. Okay, so now let's get to something more interesting. What about floods? So I've been giving this talk for a while, so this is an old example now, but this was the South Carolina flood in 2015. I don't know if you remember.